Looks like we have our prerequisite Saturday afternoon emergency call just as soon as you get home for the day, but that's just the nature of the beast this time of year. This particular case, the landlord provided me with the tenant's number, said I needed to talk to him urgently. Gave the tenant a call, and he was working around the yard with some trimmers. I don't know, a hedge trimmer or possibly string trimmer. Either event, he was working around the outdoor unit messing with a particularly stubborn branch, and you can probably imagine where this is going. As it cut, suddenly he had a cloud behind his unit. Did talk to him a little bit, got him to run inside, turn the system off as quickly as he could. Hopefully the unit had a safety switch of some kind to shut it down if it was running in low pressure. We won't make it here in time to save any refrigerant, but hopefully we save that compressor from either running in a vacuum or pulling in too much air. But we'll get over here, see if we can hopefully patch it up and get them going again and have them cooling by the end of the day. But let's see what we find in here. Yep, I'd say he got it pretty good. There's a cable here too. It looks like TV. Yeah. And yeah, pinched it pretty good there. So we'll probably just cut this section out and braze in a new piece. This guy is going to be an R22 system, so we will have to retrofit it with a drop-in replacement. People don't think about it a lot. They think reaming is really more for doing flare fittings. In reality, if you're ever trying to use a tubing expander to swage these open and you have that little bit of a burr, I don't know if it comes out good on the camera, around there it can actually cause this copper to rip. So we do want to ream these out. It looks pretty good. So we'll use our tubing expander here. Or if I had a 3/8 coupling, that would work as well. But essentially that just expands the tubing up so it should slide on. As you've probably heard me say, somewhat of a stickler for sanding, just because I like to get as much chance as possible for our silver to bond. Using great measuring techniques, we'll cut it about there. Again, you want to kind of go slowly with these because you're really using more time and pressure in an inclined plane to slowly push the copper apart more so than cut it. So if you try to do it quickly, you'll end up causing a big burr. Take our new little piece, slide it right on. Do that one somewhere right below that little cut. Again, using expert measuring techniques. As you can see, clipped it pretty good. So there's our new little section. So when I talk about nitrogen purging, I'm literally talking about running an inert gas, nitrogen, through these lines so that we don't cause any scaling. Scaling is caused by oxidation because as your oxygen or air in these lines gets hot enough, it actually builds up a residue on the inside of these lines. And as the unit's running, turbulence through there with the liquid or vapor, what have you, oil seeping into it, can break that loose, and it just floats around, causes all kind of havoc, clogs up things. So kind of a nightmare. So what you do is essentially hook up your manifold exactly as if you were checking the refrigerant using our little service ports here. And in this particular case, we are just bleeding an inert gas, just a little trickle of it through this system. So we'll hook up to my nitrogen reg here, and on the bottom of it I have a little flow regulator, and we will switch that over to braze. So it's only pushing through just a bare amount. And we'll go ahead and disconnect this line, make sure our gauge is closed on that side anyway. Open that one to let it bleed through a little bit. When we're brazing, we're not actually trying to build up material around the outside of this fitting. We're trying to get the solder, which in this case is a high percentage of silver, very close molecularly to copper, heated up enough and you can get it to run into these joints. So the strength of your braze is actually in here where the coupling is. So having a huge pile of solder around the outside doesn't really mean it's a strong joint. So you want to use your temperature to draw the solder as it melts into these cracks up and down. I hear a lot of new guys, how do you solder upside down? Our heat and our solder will cause it to pull up anyway. So same principle, we heat up the center section and let it draw either way. But as you can see, this is an example of the oxidation we're trying to prevent with our nitrogen flow. It's very, very hot right now, so I don't want to touch it, but you can kind of see how that flakes off. That's literally on the inside of these lines if you do not nitrogen braze. And not a good thing to have running through your units, so always use nitrogen. I don't feel anything right away. Nor do we see anything. So this is what we would refer to as a cheater cord. So between line and line we have 240 volts. Going between line and ground then on either side is 120 volts. So we can connect our neutral and our ground, just both to ground, and connect this to either side of the line voltage. And now our plug has 120 volts. So we're able to cheat and grab some power essentially without having to find an outlet a mile and a half away. We have been holding a vacuum for a little while now. This particular unit, I cannot actually see what the factory charge was. It is going to be off anyway just because we're not using R22, but the label's so old there's really no telling. So what we'll probably do is let it pull in ambiently with the vacuum we have applied and see how it runs. Then we'll use our wet bulb and outdoor temperature, dry bulb temperature, to come up with an approximate superheat from it and charge it from that. Our 453A, which is a refrigerant we're using, and go into our menu, target superheat, enter, our indoor manual, enter. Looking like with that particular refrigerant, with our indoor wet bulb, outdoor dry bulb, we'd be looking at a 26.2 degree superheat in this particular case. Alright, looks like we hit our target, so we'll disconnect. Basically, I turn off the tank valve. These are quick connects, so we do have a good amount of liquid, 4 to 6 ounces of liquid refrigerant in this hose, probably about the same in this one. So rather than waste that, we can use our manifold to just pull it back into the unit. That way they get everything. So a fun little diversion on a Saturday afternoon. That happens more often than you would think. Typically though, it tends to be the low voltage wires. Those bundles are normally jacketed in like a brown or tan material. So very easy to mistake for foliage when you're trying to clean up behind the unit. The line sets themselves, as you saw, they do kind of weather, oxidize a little bit, become a darker color. Same thing, very easy to mistake for dead foliage or something, or a stick. This particular case, he was unfortunate enough to actually have cut into it and vented all of his refrigerant, so we were forcefully evacuated. Easy enough to repair. We just made ourselves a little coupling with some 3/8 tubing. Did kind of show you the importance of both deburring and nitrogen brazing. You want to make sure you deburr. A lot of people think you only need to do that to flare. However, if you try to expand that tubing and the burr is just right, it can rip the tubing. So you have to do it again. So easy enough, spend a second, just deburr them. Same thing with nitrogen brazing. You saw the outside of that tubing. That material that formed is referred to as scale. It's kind of like an oxidation due to the temperature of the line getting so hot. It develops that scale, and will also develop on the inside of that copper if there's any air present. So always be sure to nitrogen purge with dehydrated nitrogen. You keep that stuff from forming inside, because once it's there, it just spreads out everywhere. When you turn the system on, clogs things up, causes wear to your compressor, various little mechanical parts. It's not a good thing. All in all, not too bad of a repair. That system was an R22 unit. Unfortunately, can't really get a hold of that anymore, so we did retrofit it with R453A. I believe the manufacturer calls it RS44B. Why not throw a bunch of random numbers and letters for no reason to confuse everybody, I guess. But retrofit it. The stuff is very close on the PT chart to R22, and it is also miscible with the oils they use, so it should work just fine. The compressor started right up. We weren't really able to charge it by any kind of charging chart due to the fact the system was not designed to operate with it specifically. So we did have to use our psychrometer to come up with a target superheat. But got him taken care of, and hopefully for the day I'm done. Gonna go home and barbecue a hamburger and grill a hamburger, barbecue, whatever. But we'll catch you next time.